Hello everyone, this is Varsha. I'm currently pursuing my BE in CSE AI department in 7th SEM in Sri Venkateswara College of Engineering. In this session, we will discuss about concurrency in NoSQL databases. Firstly, what is concurrency in NoSQL databases? Concurrency in NoSQL databases is crucial for handling multiple requests simultaneously. These databases offer various mechanisms to manage concurrent access and ensure data integrity. Uh, Let us see why is concurrency important. Uh, there are three main reasons why concurrency is important. One is simultaneous operations, other one is data integrity, and other one is performance optimization. Simultaneous operations means this concurrency involves multiple operations happening at the same time, often from different users or processes. Data integrity. Data integrity means it is essential to manage concurrent access to avoid data corruption or inconsistencies. For this purpose, data integrity is a very important. Next, performance optimization. This concurrency allows databases to handle multiple requests effectively, boosting overall system performance. Challenges of concurrency in NoSQL. One is scalability, fault tolerance, and the data consistency. As we discussed, maintaining a data consistency in a distributed environment is a very big challenge. Next, scalability. When we come to the scalability, handling increasing when many workloads or data volumes will increase, uh, while ensuring concurrency is crucial for the performance. Next, fault tolerance. Databases need to handle failures and maintain data integrity even when nodes are unavailable. This is one of the challenge. Even eventual consistency versus strong consistency. Let us see the differences between the eventual consistency and strong consistency. Firstly, let us discuss about the eventual consistency. In eventual consistency, data eventually becomes consistent after a period of time. This is suitable for applications that can tolerate some delays in data synchronization, which will tolerate the delay. We'll use eventual consistency. When it comes to the strong consistency, data is consistent immediately across all the nodes. The strong consistency is used when we want the data accuracy very immediately. That is, it is essential for the applications where real-time data accuracy is crucial. Next, locking and isolation levels in NoSQL. Locking. Locking mechanism restricts the access to the data that ensures that only one operation can modify it at a time. It means locking when someone is doing some modification or operation on a data. When other person does, it doesn't allow that other person to access that data. It locks the data so that only one response goes to the one data. Next, if you go to the isolation levels, different isolation levels define the level of consistency and protection from concurrent operations. Data integrity. By ensuring the proper locking and isolation levels, we can integrate the data well. By using the locking mechanism, we can avoid the conflicts while anyone modifying the data at a time, one or more person. So by using this locking mechanism, we can integrate the data properly and efficiently. Next, multi-version concurrency control means multiple versions. Like this multi-version concurrency control maintains multiple versions of data. It allows concurrent operations to access the different versions. Next, snapshot isolation. This is each transaction sees a consistent snapshot of data and it reduces the need for explicit locking. Next, increased concurrency. This multi-version concurrency control allows for a higher degree of concurrency when compared to the traditional locking mechanisms. Next, optimistic concurrency control. In this assumption, check and set conflict resolution. This optimistic concurrency controls assumes that conflicts are infrequent, so transaction proceed without initial locking. Before committing any changes, this optimistic concurrency control verifies that no other transaction has modified the data. Next one is conflict resolution. If a conflict is detected, the transaction may be retried or handled differently depending upon the implementation. Like deck, DAC, check, deck, sack. Next, distributed transactions in NoSQL. Distributed nature. This distributed transactions span multiple nodes in distributed database. These transactions must be atomic, either succeeding entirely or failing completely. Consistency. Data consistency is maintained across all involved nodes during the transaction. And locking challenges is managing distribution l- locks and maintain the data integrity. Next, handling conflicts and failures. Conflict detection. Mechanisms are needed to detect the conflict between current transactions. This conflict resolution. The databases employ strategies like retrying transactions, aborting them, or using conflict resolution rules. Next one is fault tolerance. Databases should be resilient to failures, ensuring the consistency and completion. The real world examples and practices are: one is e-commerce, social media, streaming services. In e-commerce platforms, these platforms rely heavily on concurrency to handle simultaneous orders and inventory updates. Even social media also handle high volumes of concurrency activity, including posts, likes, and comments. Next, streaming services. These, streaming services also manage a large number of concurrent usage content requiring efficient management.